I've gotten a lot of requests through PM on what I've been doing with my rear end for my Packard. 56 Packard Patrician 5682. That comes with a Dana 53 rear end. Dana 53s are a rare oddity. They were an oddball in the Dana process. They're mainly used today. You can find them on a lot of Jeeps and four-wheel drives. However, they're a bit different. So what you'll find when you go to rebuild your rear end is you're not going to find very many parts for a Dana 53. Very, very rare. On the Patrician, I happen to have a twin track. So you will not find spider parts and that for a twin track. So if your carrier has problems, you're going to have a little bit more difficulty. But what we're going to do today is a master rebuild on the rear end. And I've been asked a lot of questions on how I did it and this and that. So I thought I'd do a short tutorial on here. A couple things I'd like to point out first. When I pulled my bearing out, you could see in here in the race, you can see these imperfections down here. And you can see there's a couple over here. In the bearing world, that's called brinelling. And what that is where the metal gets fatigued from impact and it just starts to deteriorate. This is what will chew your gears up and pit your teeth. Also, it makes a bearing failure because the bearing is going over those potholes. That's just like driving over a pothole in the road. And of course, when you're doing this under load and at speed, your bearings will start to disintegrate when this happens. So this was the main reason for my tear down in my rebuild. So with that said, that's why we're starting with this. Today we're going to be doing a 43-14 gear ratio rear end. Now, a lot of us are back tree mechanics. We do things in our garage. We don't have access to the fancy tools. And anybody that's working on Packard knows that the special tools that are available for Packard are very rare, very hard to find. So to get tools that are in the manual for this, we're just not going to find out there unless you have somebody that has them. So one thing we could do is we could go get a universal measuring deal to set our pinion height and all that. But again, using the universal, you're having to measure to find the deepest setting in your bearing housing, so you have to move your gauge around a little bit. And again, that's just a starting point in guesswork. What I'm going to show you today is a very easy way to do it. In the end, we wind up in the same place, and we don't have to have all the fancy equipment to do so. So since I'm not changing gears, I'm using original gearing, my shims should not change for my pinion depth. So I've gone ahead and put my races in, and under this race here I already have my shim pack that came out of the original. For the 56 Patrician, you want a height of 2.688, which is going to be from the top of your pinion to the center line of your housing, or your axle. So again, because I'm not changing gears, I should be very, very close using my original. If not, then I will have to take out my race and add some shims or take out as needed. But for a starting point, we're going to start there. If you were changing shims, I find usually about 60 thousandths is a good place to start in your alignment. So we have that in there. So what we're going to do first is we're going to set our carrier, and we need to set our carrier for zero backlash, or not zero backlash, but zero wobble in our housing. So what we're going to do is we're going to start with, one thing I want to point out. You can get a master rebuild kit from Yukon Gear. And Yukon Gear makes very high quality parts. You can get a complete Dana 53 kit, which comes with all bearings, seals, pinion, and carrier shims. Or in my case, it was cheaper for me. Those run about just under $400. I was able to rebuild mine for just over $200, doing things separately. So what I did is I bought a carrier shim pack, SK30214. Now you won't find this under Dana 53 because, again, as I said earlier, Dana 53 parts you can't find. This is for a Dana 44 rear end. It just so happens Dana 44 and Dana 53s use the exact same carrier shims. So a Dana 44 pack will work perfect for this operation. As far as the pinion is concerned, the only thing available will be SK-GM 9.5. So your pinion shims are the exact same as a GM 9.5 rear end. Same thing as the Dana 53. So you can get serviceable parts, they're just under different part numbers. So what we're going to do is, one thing I can't stress enough is make a set of dummy bearings. If you don't make dummy bearings, you're going to destroy bearings. It's going to take you 10 times as long. We can actually set this rear end up here in about 15 minutes going from scratch. So what we're going to do is we're going to start with 50 thousandths on the ring side. The reason being is when I took this apart, 50 thousandths is where we were at. The reason I'm doing this, and if you've seen my other video, I had excessive backlash. I had about a quarter turn in my yoke flange when this was put together. I had about a quarter turn of backlash, which is way too much. Packard wants 3 to 6 thousandths backlash in our ring gears. So for a reference point, I'm going to go ahead and start at 50 thousandths because that's what I took out. I'm going to take my dummy bearing, slip it on. Now again, if you don't make dummy bearings, you're going to be pressing these on, pressing these off, and you're going to be cussing quite a bit. So I'm going to go ahead and start there. And then let's go ahead and put it in and see what we got. So I'm going to put my bearing way out. Go ahead and put my bearing on this side. And we're going to simply drop it into the housing. And again, watch your fingers when you do this. Okay, so now we're in the housing. You can see we have freewheel, so we don't have any preload on these bearings yet. So what I want to listen for is, do I have any lateral movement? That's still slopping around in there. So we are not at full capacity yet. So again, like I said, you could go through fancy measurements if you go through like the book, and it'll say push this over, measure your gap, then you'll have to divide side to side. That's all great, but you know, you don't have to do all that fancy stuff. So we're going to pull this back out. And again, I'm using dummy bearings, so that doesn't matter. And I'm going to put 30 thousandths on this side. And we'll start there and see how we are. Okay, and we'll drop her back in there. Oh, I have no movement. So we're pretty much at a 0 preload now. So again, Packard wants about 7 thousandths preload when you get ready for your final run. So we'll worry about the preload later. Right now we're just setting. So that's real good. We have movement. We have no movement side to side. So now what we need to do is start setting up to check for our backlash to see where our gears are at. So again, you know you're there when this is just give you a little bit of resistance to pull out. You know you're there. So wrestle that back out of here. Okay, now we'll start. So we're going to call that good. So now we're going to start with our pinion. Okay, our pinion, again, our shims are already down in our housing. If you need to shim, you can put a dummy bearing on here to make height adjustments. I didn't do that. I'm running a live bearing on here right now. So one thing to keep in mind when you set your pinion height is off of your front shims in the front of this pack. So by putting shims in, I'm going to push it up. Taking shims out, I'm going to move the pinion down. That is the only thing that adjusts the pinion height, the pinion movement in this process. So by using dummy bearings, real quick, simply drop your pinion in. Okay, you can see, spins freely, no preload. Now, you can waste your time, as the book says, pressing this on, pressing this off, yada yada yada. Takes a lot of time. All you really need, just made a little sleeve. And I'm going to take my sleeve and I'm just going to put that on there. And there you go. If it takes you any longer to do that, you're wasting your time. But you know what? It's not going to work because we didn't put the bearing on there. So no wonder we have so much slop. So again, another dummy bearing. So it just slides in, slides off. Dummy bearing, spacer, nut. That's better. Now you can see we have no backlash in the pinion. And you can see that pinion doesn't slide now, or spin. So we have a little bit of preload going on already. Okay, now the book talks about putting the yoke on and tightening down to 220 foot-pounds. We will do that, but we'll do that later. We don't need that initial preload to set our backlash. All we're worried about right now is that we do not have any backlash in this bearing, which we don't because we've tightened it. We have preload because we don't have the spin. That's all we have to do. A lot faster. Now, if you had to go back and re-shim, you can see how fast it is to take that out and put it back in. You're not going to spend 20 minutes trying to press the bearing off, press it back on. Okay, so now that we've done that, we're going to go ahead and put our carrier back in, and we're going to check for backlash. So let's go ahead and drop our carrier back in here. Okay, that's pretty tight. I got good movement, but if you hear, I got no backlash. Okay, so what we got to do is now we got to establish some backlash in there and get a starting point where we're going. Now, since we've already put shims in both sides and we don't have any lateral movement, we don't want to change any of those dimensions. So whatever we do to one side, we have to do to the other side. So again, I have no movement in there, so let's take this out. Okay, so we started with 2 shims at 30 thousandths. So we had 60 thousandths in there. Or excuse me, 50 thousandths. We started with 50 on this side. So I want to take out, I want to take out about 5 thousandths and see what we get. So I'm going to take that 10 out and I'm going to replace it with a 30 and a 5. So now, since I took 10 out of that side, I've got to put 10 thousandths in this side so that we shift it over. Oh, got a little snag there. Aaron, if you could hand me my little mallet. There we go. Okay, so I've got a 30 in this side, so I want to take out. So I'm going to take that out and I'm going to put a 20 and a 5 in there. It helps you put the bearing on the right way. Silly boy. Now we have backlash. You can hear it. So we've established backlash, but we want to wind up between 3 to 6 thousandths. Let's go ahead and measure and see where we're at. I think the trash was just taken out. So let's go ahead and get this set. I'm going to pull it back here where I can see it a little bit. Okay, and we're going to adjust this down to 0. Let's see what we have for backlash. I buggered that. Helps if you move the right way. Now I'm moving around here. Let's reset my gauge here. Get that on there. There we go. Didn't have the magnet on there very tight. These things can sometimes be a little bit of a pain to deal with. Okay, you can see I've got 3/1000s. 3/1000s. So that puts me right in the spec. Back to 3/1000s. Okay, so let's go ahead and roll this around again. And let's check 180 out. Oh, I'm wiggling again. Let's reset that. Get that up here where it's supposed to be. Coming loose here. And once again, I'm at 4/1000ths backlash. 4, 4, 4, 4. So as I'm 3/1000ths on one side, 180 out, I'm at 4. Packard wants 3 to 6 with no more than 2 thousandths variation between readings. So that's good to go. Let's go ahead and check our run out now and see what that looks like. For run out, Packard wants no more than what was it, 4/1000ths I believe, trying to go off memory, but let's find out where we're at. Get this all set up here. Alright, let me get up here where I can read it. There we go, running about 2 thousandths run out. So, really, at this point, we could go ahead and run this unit as is. It would be ready to go. Now, what I would do is let's go ahead and check our gear, and we'll use a little bit of gear smear here. Stuff everybody loves to paint with. Sure we get front and back there good. Now what you really look for in a gear pattern is you want your pattern to pretty much be centered on your drive side and your coast side. But because we're using a used set of gears, what I'm anticipating seeing is a centered pattern on the coast side. Then I'm going to look for the drive side to probably be more down here by the toe than the heel. And the reason being is, again, as this gets under load, if it's down here, it's going to move towards the center anyway. If we put it in the center, then again, we could push it off to the heel and have a bad pattern. When you're adjusting for your gear pattern, your backlash will move your toe and heel up and down together. So your pinion height will adjust this way. So moving your pinion height up or down will move your pattern on the coast and drive side, side to side. Your backlash moves them laterally together. So let's see what we got. I'm going to go ahead and put just a little bit of back pressure on this ring, and let's run it through here. Okay. You see the pattern is fairly centered, coming right off the heel. And on the drive side, yep, it's down here by the toe where I expect it to be, but it's centered top to bottom. And then as that gets under pressure, that's going to move over a little bit. So with that right there, I would run this rear end just the way it is, and it was just that quick. One thing I want to point out too is cross-referencing in our computer system. I have listed in there a cross-reference for a SKF seal. These came with trossel seals, which are no longer made, and so I crossed it from a trossel. It crossed directly to an SKF 51-141. That is wrong on the site. The reason being, this is a 1/4 inch thin shim or seal. We don't want that. What came out here are 1/2 inch seals. So again, I crossed the SKF to what it should be, which comes out to be a 450067. That's our full 1/2 inch double walled seal. That's exactly like the trossel that came out of here. So again, these are the seals we'll want to use in our end caps. One more thing to do for a complete restore and we're done is, again, can you hand me the axle behind you there, bud? Is when you get ready to replace your bearings on your axle. So these are sealed roller ball bearings, and they come with a kind of a compression sleeve that locks the bearing in place. One thing you do not want to do is do not try to press the bearing and the collar off at the same time. If you do, you'll gall your housing and your bearings won't fit on your next housing. So these bearings, again, come from Timken, made in USA. And what you have is you have your bearing, and then you have your locking collar. Bearing will go on, and then you'll have to press your locking collar on for that. Now, to get that locking collar off is really pretty simple. All you do is you take a cold chisel, you put the cold chisel on that locking mechanism, and you simply crack it with a hammer. Rotate it 180 degrees, crack it with a hammer. What that does is it fractures this, and that sleeve will come right off. Then you can go ahead and press your bearing off, get yourself all cleaned up, put your bearing back on. But again, when you put it back together, do not try to press both on at the same time, because again, you'll have the same problem. Put the bearing on, and then put your locking sleeve on. Once you're done, you'll have a clean rear end ready to go, and I expect a lot of life out of this rear end. So one thing I do want to point out before I go is we talked a little bit about the Brinelli. Believe it or not, guys, bearings are very, very sensitive. They're durable, but they're sensitive. When I was playing with this earlier, I was trying to do it by the book, and I was actually having to knock and tap my carrier in. Well, I want to show you something that happens when you do that. These are brand new races. These races run about $30 a piece. So They're cheap, but they're not that cheap. And what I want to point out is by knocking it in and out, I talked before about Brinelling and the vibration. I don't know if you can pick this up on camera, but you can see right through here where the roller balls impacted when we were tapping, impacting. That is what's called a false Brinell. Smooth, you can barely feel it, but what's going to happen is that's going to start potholing on you, just like this one did. That's what causes the potholes. So if I was to put this race back in and run it, I will have a rear end failure in a short amount of time. So I'll be replacing this with a new one before final assembly. So just want to point that out. If you even so much as take a bearing, and this is a bad one so I can do it, but let's say you have your roller bearing here for your rear end. If you were to accidentally knock it off and just drop it, throw your bearing away. Believe it or not, that little bit of impact destroyed that bearing. Because what happens in here is when you drop that, the same thing happens. That vibration will Brinell your race, and you will have a bearing failure. Bearings, it drives me nuts when I go to a parts store and I see them storing bearings on their end like this. Bearings should, if you see them like that, you may not want to buy them. Bearings should always be stored flat. The reason being is, again, just sitting on the shelf, just vibration will cause a Brinelling in the race. Again, industrial maintenance for many, many years, just vibration of bearings being on the shelf back in the maintenance shop, and we have 200-ton presses out in the shop, not even near our plant, but just if you've ever been in a heavy industrial plant, you can feel the vibration on the floor of those presses going boom, boom. That's enough to destroy a bearing that's sitting on the side. So again, store bearings flat, and every couple months, rotate them. Get the grease smeared back around, put them back up. To do that, you'll have good bearings to go. So what we're going to do is we'll just go ahead and drop this back in for light of conversation. Get this here. It gets a little tight. There we go. Okay, so now that that's ready, the only thing left to do is to set our preload. So again, we're at 0 preload now, or near 0, because we have no movement. Packard wants 7 thousandths preload. So what I'm going to do is, again, your shim packs come in 3, 5s, 10s, and 30s. I'm going to take a 3 and a 3, and I'm going to add to each side. When I do that, put this back together, I will have my initial preload. Now, because that's going to get tight, I might have to use a case spreader to get that back in here. But again, adding these two 6,000 or 3,000 shims will give me my preload, and then I'll have a rear end that's ready to bolt up and go in the car. So, pretty simple. Don't want to oversimplify it. You know, this is critical to do. But again, if you were to run all those fancy measurements, we was going to wind up in the exact same place we are now. So that's how you do a Dana. You can see it took 15-20 minutes. Gonna put her in the Patrician, and down the road we go.